virtual piracy sort of worked better for it. And I usually start by getting to know the audience just a little bit. So I've been dealing with DevOps for about 8 years now. Actually, I started with Lars Kruse a long, long time ago in a place called Pragma. And then sort of doing it on off a little bit. These days, I'm the CEO of a small consulting company, and my co-founder is here as well. So it's nice to get to do these sort of things. I'm really passionate about flow, quality, and everything continuous improvement. There's a special something to speeding up things, making them better quality, and getting business results faster, and getting to be technical about that. And I think that making a difference this way, it's more fun for me. And so for those of you wondering, what are these three portraits, I usually try to figure out, by hand raising, how many of you think of yourselves as developers, as operations staff, and as others, usually as manager, but this time we'll go with others. If you're a tester or similar, project manager, whatever sort of clings to your boat most, if you can raise your hand. So, for the developers in the room, can you raise your hand, please? Cool. Ops? All right. And the other category, the rest? All right, cool enough. So, I have this fictional company called The Pirate Way. Not at all, well, that's interesting. It's a bit dark on the screen. I apologize for that. So the Pirate Bay, of course, has nothing to do with it. And it's just sort of to have something to refer back to. And what we're looking at is a traditional company. I think for the point of the presentation, I'll just have it as a little backside story. It's not really the essential part. But what I call a traditional company is some sort of company that wasn't a software company and then fell into software and woke up one morning realizing that if they don't have a software department, they cease to be a company. It's very typical for all kind of finance service, any kind of like physical product who end up as e-commerce, that sort of thing. So they're not really a software company at its core, but they've come to rely so much on software that they're forced to play with the rest of us. And typically, not all of them, but they have a traditional culture. And so they're a bit slower than sort of a software native company. They typically have something like releasing quarterly. They have this sort of, it takes a long time to agree with everybody what's a good idea, can we put it out in production, can we do something about it? Every release introduces some sort of problem where we forgot a thing or something went down or something was a problem. And, generally critical problems can't be expedited. They have to go through a long compliance process. And sort of for the purpose of this talk, I would like to then talk about that type of company trying to then move from a virtual machine setup into a little bit more modern infrastructure. Just for the fun of it, let's say that we have an org chart. So we have a CEO, Mr. Captain Barbosa. We have some sort of project management office. Those of you who watched Pirates of the Caribbean will relate. And we have some project managers running around doing their thing. We have some technical people. For the point of the talk, we'll have a tech lead. And we'll have some engineers, as well as two sort of middle layer, an enterprise architect and a line manager. I think most companies that have grown to a certain size look something like this, and let's not forget finance. And it's usually at this point that they then wake up and go, hey, we're having some problems growing, we're having some issues scaling our stuff. Mr. Jack over in the corner will then point out that the software, they're of course a software-driven, hyper-innovative technology company, right? That's sort of the bottom and the clinging to it. As you'll notice, those letters denote something very special for them, yeah? A lot of companies really do see themselves this way. They just don't really say it that way. And often what then happens is that some technical person steps up and settles on a new tech stack. And for the point of my presentation, it'll be Kubernetes, but really it's not so important what the technology stack is. It's just this sort of deeply integrated need to migrate to something new and to fix a problem that's been wrong for a while. A lot of the time that's containers, some of the time it's cloud, some of the time it's a totally different technology, but sort of the idea stands. And let's do that the enterprise way. So we'll start with something that's on-premise. For this purpose, I'll use my laptop rather than a fully blown VM. I've made a very simple C# project. I literally just went and wrote .NET New. And we'll sort of act as if that's a VM, right? And if we were to scale that, let's say that that was our super duper important service, our streaming service, we would have to create more environments like this. We'd have to maintain them, we'd have to remember what we put in them. And for those of you in the room who've worked with any sort of infrastructure as code or any sort of modern infrastructure, a lot of these things are going to be very trivial, right? But you have to consider a lot of these things are not really given out of the box, right? You have to think about your load balancing. You have to think about your security. You have to think about all the little things of how do you deal with this, right? And so just a quick show of hands, how many of you work with Kubernetes on a daily basis or at least weekly basis? Okay, so it's going to be about the right level then. Let's find my terminal, find my repo. Think I called it that? Yeah. So here we have my, you can't see that, can you? That should be better. Here we have my very simple repository. And so if we look inside the app folder, this is how a fresh .NET application looks when there is nothing done to it. And just to show you how that looks, we'll run that. I also can't spell today. Yeah, it's a bit slow. There we go. Right, so it's a pretty boring sort of, scaffolded website. There's nothing to it, but it's running an app. And it's good enough for the purposes of sort of showing the infrastructure underlying, right? And so when we then return to the sort of, how does that look, right? This is pretty fairly typical for like some sort of on-prem running architecture. You have a firewall, you have some stuff, you have some DMZs, demilitarized zones, you have some sort of encapsulation that protects how you run your stuff, right? Otherwise it's open to the whole world. And then you have a bunch of servers, in this case that would be our application running inside different places. We might have a network that connects to a bunch of workstations, whatever. This is pretty typical. But so when we then start modernizing, we start by going, okay, we have these VMs, we want to move them into a new thing, and so we start making a plan. I think this is typical for most companies. And we envision this really nice little journey where we say, okay, we have this on-prem operations, we want to move to a cloud, we want to move to something, in this case Kubernetes. We also have to not forget our compliance, and we have to remember our ISO certification, because we have this long laundry list of things that need to still be true, right? We had this whole setup on-premise, and we need that new setup that we're going to go, in this case Kubernetes, to also follow whatever rules govern our business. And very often, it's a little bit more windy. We have some cultural problems we're dragging along with us. We've bugs on this legacy project that we want to move. We've problems with our flow, with our lead times. We generally tend to have these short-lived deadlines that are really important to us, also known as projects over products. We have these undercurrents, our political challenges. In this case, I've decided that our enterprise architects don't really like Kubernetes. They feel like it's dangerous. Finance doesn't really like this promise of like, you're going to do a bunch of engineering work and you're going to be the same place you started. And it'll be a variable cost, because if we scale out on all the servers, then it'll cost more than if we just scale to some of them. And somebody somewhere in the business promised a deadline. And I think most migration projects really have these underlying problems. And similarly, we have some technical headwinds, right? We're learning a new technology. We don't really have a lot more time because we're still fixing the old stuff and still figuring out how to run the existing service. We have a bunch of tech debt, a bunch of architectural problems. And to make that worse, when we then don't understand the technology, we're also going to commit some missteps as we go along, just to sort of set the scene, right? So even though what we're going to do today is fairly straightforward for those of you who've worked with Docker before, we still have to keep those things in mind when we do any sort of technological migration. And so specifically for Docker and for Kubernetes, the base idea is that we have a Docker file, and rather than having whatever's on my laptop, we put that in a Docker file, right? Then we have the early Kubernetes manifests. We have various YAML that describes different states in Kubernetes that we'll need. And then we have automation, and possibly we have cloud. I'll see how much time I have, but I'm going to try and make it. Now, for those of you who haven't seen a Docker file before, I have made one. This looks like something else. Let's not keep that. Where do I keep my stuff? My source. Yeah, sorry, I should have prepared this. Right, so let's just open, actually, yeah, sure. Right, so a Docker file is basically a way for us to then take whatever that VM was from before and describe all the things necessary to create a similar state. And I'm not using a dev container. I probably should be, thank you, Lars. But this is in its sort of basic puzzle pieces. It's some sort of state I rely on, coming from the top. In this case, I want the .NET SDK because it's the simplest thing. I then create a folder. For those of you who aren't familiar with .NET, I restore the dependencies that I need, run my tests, and then publish only the things I need to run in production. And then I put that in a different container down here so that it's leaner. It lets me sort of get rid of a lot of the test files, a lot of the other stuff that I don't necessarily need for production. So it makes the thing lightweight without a lot of dependencies that can be sort of dragged around that don't really do anything. And then I run that. And so if the demo gods are with me, we should be able to do that, right? So in this case, actually, let's change something in the app, just so you guys know I'm not messing with you. Let's see if I remember my .NET. Yeah, this thing says homepage. Learn about welcome. All right, so we'll say welcome Tech Collective. All right, let's do that. And so when I build the container, I give it a name. In this case, I have a previous build that I've actually uploaded to Docker Hub, where the container is called, you guys can't see that. Yeah, if we do it this way, maybe it's easier. So in this case, my username is Shara, and I'm using the free GitHub version. And so the application is called the Pirate Way, and I've denoted a version 1.0.2 using basic Semver. And it's just a way for me to version the artifacts so that I know what the difference is, right? When I built that, it starts building all of the things you saw in the file. It'll then take the first container, which contains the SDK and all the things I need to test and to run, and then it'll sort of publish that and throw it over in the other container, and that's the whole build done, right? And when that's finished, we then push that up. A lot of this you do in a pipeline, right? You push the app, and I called it 0.2. And we do this for like every application we do in Docker and Kubernetes, etc. For those of you who worked with it before, this makes a lot of sense. This is not that different from what we would do for a VM, where we would save the built files, we'd version them somewhere, we make sure we have them. It's just that when we're doing a container, we have a guarantee that even if I was to log on to a server and change something, that would stay there forever. But with a container, when I then spin up a new image, it's fresh. Yeah? So I know exactly what I'm getting. I'm not getting anything different. And I don't need to rely on somebody remembering how you configure the virtual machine so that the application can run, right? You always have a state that sort of is equivalent to what is in this Docker file. Just for good measure, I did push it, right? Yeah, so maybe I have that open somewhere. I do, lucky me. Right, so this is the repository that I'm pushing to. If I'm a little lucky, then you'll see, yeah, here we are, right? The one I just made is this one, 0.1.2. It's sort of visible to you down on the bottom. And then this is a container image that's public, so if any of you felt like taking it or running it, you can have exactly my little app that does nothing, and you can run on any local machine, right? So moving on, that's sort of the basic of how we deal with Docker. Now, Kubernetes is then, oh right, one of the more thing to mention is that the .NET image that I build on, if you're ever curious about what's in it, there was a question about compliance earlier. The custom is that you then are given the public Docker file and you can go and see which dependencies are you building from, and you can sort of track the whole list of things. You can also inspect the image and get a feel for what's actually in there, so you don't go in necessarily blindsided of like, I have to trust Microsoft on this. You can actually go and see what's in it. Right. Yeah. Let's do 4. Right. So coming back to Kubernetes. Kubernetes is then a way for us to run Docker in a more production-ready environment. Docker has this thing where, at least in the early history, it would not really run on its own without falling over. So after a while, the Docker image would be running and running and running, and then it would fall over and not restart. And so Kubernetes sort of puts a layer on top that allows you to watch the container and make sure it runs at any given time, as well as sort of some of the networking stuff. So how do I make sure that my container can be reached from the outside world? How do I deal with security? Some of those things come from Kubernetes. And again, we have this idea of, where's my, here. We have this idea of Kubernetes as a basic sort of descriptive way of saying, you know, how does stuff look to us, right? In this case, this is a deployment. A deployment is a thin layer on top of the Docker container, which then explains to it, hey, I would like, in this case, 3 Docker containers to run side by side so that I have redundancy. In case one of them flops, then the others will take over. I'd like to run, a lot of these metadata things is sort of Kubernetes itself can figure out what am I trying to find and how does it collaborate with other services. And then we have the image that we just made, right? So let's change that to the freshly made one. I'll start up Minikube, which is a local Kubernetes cluster that you use for local development. It's not quite production ready, but you can do 99% of sort of basic stuff for sure. And it's an easy way to test out what you're doing and if it's working. I probably should have spun it up as well preemptively. And then we're going to try and deploy things into Kubernetes, right? And again, this is how that journey would look for a lot of companies. You'd pick a tech stack, you'd set up a basic prototype, you'd roll out your files, and you'd sort of start evaluating at this point, does this tech make sense for us? Is it solving some of those basic problems? In Docker's case, we're getting the direct recipe for how we'd like to run things. We're getting a lot of knowledge here that we didn't have before. And so the command line tool that you interact with Kubernetes is called kubectl. And here we're going to deploy the deployment. So what this then does is it takes this YAML file that you saw before, and then it gives it to Kubernetes and says, please run this. This is the state I want. You figure out how to do this. So it's declarative in the way that if I tell Kubernetes now, oh, I actually want 5 replicas, it'll then look at the thing and go, oh, I have 3, so I need to spin up 2 more. If I then tell it to go down to 2, it'll say, oh, I have too many. I need to kill off some of them. And what we get from this is we get what's called a pod, which is just a container. That's a little bit too many because you guys will get confused. We've deployed them in the default namespace. And so here we have our 3 Docker containers running side by side. They're both ready and up, and they're all running and they haven't restarted. If I was to kill one of them, just for fun, if I can remember the syntax for it, it's been a while, delete pod, this bad boy. So we're deleting the first one, and then we run the command again. You'll see 3. But the one that I just killed is gone. And so what happened was the Kubernetes was told, you need to have 3 running instances at any given time. And then I killed 1, so it only had 2. And then before I could even ask for the command again to see them, it spun up a different one and restored so that I had 3. Now, a lot of this gets a little bit hairy. And so one thing we can do is we can ask to see how, was this the right way? It's been a while. That's for the service, that's not what I want. I have it otherwise, but port forward isn't that? Oh, okay, I'll cheat. I have it down here, blah, blah, blah. Right, it needs to. So you can port forward and say, I'd like you to tie the container port that's running inside Kubernetes to port 30,080 on my machine. And this allows us to find our container inside the cluster. So now what's happening is that the cluster is opening a port outside to my local machine, and then I can look at my container. It's nice for a little development step, right? So we're doing it very, very incrementally. We started by making the container. We could run that and show that it works. Now we put the container inside Kubernetes, and then I'm running that from there and looking at it, right? But if I'm not doing that, if I just do this, then there's nothing to see. So my service is running inside the cluster, but nobody can access this. That's a bit useless. The way that Kubernetes exposes things out through is via service to start with, and then later on via an ingress. I'll get back to what that is, right? So let's try and apply the service. Oh, I already had. I should have probably deleted that. The service, what it does is it links up and creates sort of what's equivalent to an API endpoint. So if you think of it as the container needing to be exposed on some network somewhere so that I can reach it, the service then puts a layer on top and says, okay, I can access your container, but then sort of all the other access to that container should go through me. That's not really a great abstraction if you're just doing one thing, but it becomes very useful for when you have a bunch of different services. My application is very simple, but if you, for example, had a database that you had to communicate with, there's a real use case to be had for the database having one place to go fetch it, and then letting the service handle, okay, like which instance of the database is currently in use, and doing round robin and all the logic around that. So what services then do is this thin layer on top of the container that if you were running Docker locally, you'd say, okay, I need this port exposed so that I can reach it. The service then creates a place for you to do that. Within the cluster, you can then access that service and not really go outside of the cluster. Kubernetes then gets a little bit complicated in the sense that to then expose this all the way out to some sort of DNS record, you need an ingress. Here's an example of an ingress. I've named the host, so my DNS name, yar.streaming, it seemed applicable. And again, I'm having to tell it, okay, like where do I find my service, on what port is it running, what's the routing logic look like? And for people who've been doing network a lot, this seems very simplistic. But Kubernetes sort of takes a lot of this network logic and boils it down into its base components. You don't really need to understand a lot of networking to understand that, well, you know, when I ask for a yard of streaming, you'll send me to / the root on this service, which then routes to the container. And it'll do it on port 8080 because that's where .NET applications run. And I might have to do something here to make this work, but in theory, it should just work out of the gates because I've enabled stuff preemptively. Yeah, it changed, cool. So these things I've pre-deployed just to make sure that they actually go through and tested them. So when I now access this thing, if I access it on, so Minikube is running a VM to sort of mimic how a real cluster might look. If you were to access Minikube's IP, it would not route through to this because Kubernetes has this funny little thing with ingress that if you don't hit the actual DNS, it'll just say that's not for me, right? You're not asking for me, you're asking for some IP, I don't know what you're talking about. So something you do have to do is that you have to have either a real DNS, or as in my case, I've cheated a little bit, and then my etc hosts file, which is a Linux trick. I've added this little record. So if I access Yara streaming right now, it'll just tell me that doesn't exist, right? There's nothing here. But if you then tell, in this case, Linux, actually that won't work. I need sudo. If I then say, okay, well, you know, I need you to route all requests to Yara streaming to the IP that my Kubernetes cluster is running. It'll actually get interpreted by Kubernetes as the right way. And so if we were to do this again now, our thing loads. If I had a real DNS, an actual DNS pointing to Minikube, in this case, it would also work. And what this allows you to do is have a single IP as an entry point for your cluster. So you get to have all your security in one place for a myriad of services, and you don't have to run around and protect things in the old way. So in a virtual machine setup, you'd have to then go and make sure that every single service had its own network thing and its own security configured, et cetera, et cetera. Here you can have a single point of entry and load balance or whatever you want. And you can put your security there and then fan out to a bunch of different services. And this is incredibly powerful for when you're doing microservices or anything of higher complexity. Right. So coming back a little bit, and I understand that this can be sort of, it's fairly straightforward, but at the same time fairly complex, coming from sort of a traditional world. Kubernetes has a lot more stuff going on with it, but this is sort of how the basic stuff looks. You have a deployment of some kind running a container, you have a service on top of it, and a routing layer. And then Cloud Native and a lot of other things have made that significantly more complicated when you start diving into it, but these are really the base components. You don't need to do a lot more to sort of get a feeling for the technology. It looks a lot like this now. So an ingress basically just says, okay, there's an incoming request from a client. We put some sort of thing in front. In this case, I've deployed an add-on that runs Nginx, which functions as a load balancer. It then catches the thing, translates it to something, and throws it down to a container. And that model replaces the old one we saw quite a while back, this one. To me, this is a lot simpler than having to keep an overview of like all various network zones and who can contact what and whatnot, and you can implement app security on the application where it belongs. Now, On the culture side, well, this is happening. This is pretty much usually always the case, right? Everybody's fighting for like, is this new technology battle-proven? Does it work? Is this how we want to do things? There's an architect over in the corner who doesn't like Kubernetes, who wanted to run on some sort of cloud service instead or whatever. You have a bunch of POs and PMs running around having to be really busy, and meanwhile, you're trying to keep up with all of the demand and your services are faltering. So you're having to do all of this while dealing with that, right? This is how it generally looks when I visit clients. And that's really the challenging part. The technology itself is not really difficult. It's dealing with all the little things that comes from the side. And then we have this sort of issue of people always mentioning security and saying, oh, you can't have that. It's very important we know what's in there. And you know, we definitely don't know what's in our current tech, but at least it's written by our people who don't know anything, rather than the other people who don't know anything. And you're battling with all of these things at the same time. You're trying to figure out if this is the technology of choice, if this makes sense to you. And so you sort of have to turn around and go, okay, like, if we're going to deploy this new, technology, it promised us speed. We sort of start having this dialogue around platform teams. Can we consolidate some of the services? How does all of this look? People need an outlet for their requests for security, for compliance, for all of these various things. And it's important to give them that. And so when you're dealing with it, it's not so much about proving that the technology is a better fit, it's about making it make sense in the business context. So it's about having something where you deploy it and it gives value. So if you're just doing it to have the latest technology, you're really not getting any benefits from it. It has to make sense in its given context. Otherwise, you might as well stay with what you were doing. I think I'm going to try and see if I can do this in cloud in the given time. I have somewhere here a trial account for Azure that I made yesterday. And I spun up the cluster because apparently that takes 10 minutes. And so here we have sort of the other step that usually comes with this, right? Because once we, technology people, get a taste for a new technology, we try to do all of the things. And so, because it's finally the chance for us to clean up, so we try to do not just the one thing, we also try to move to cloud, and we try to clean up the code base at the same time. We try to get rid of all the technological debt, because for once we've been given time to do something that we care about and not just business, which, is a bit unfortunate. Let's see if we have time for this. So what I'm doing here is just authenticating and getting the credentials in the fastest and easiest way possible. When I run my commands now and ask what's in the cluster, it's empty, because it's a different cluster. This one's running out in the cloud. But the beautiful thing about this is that I can still just take the files that I had before. Fudge love. Can I just force that? Nope. Yeah. Okay, I know what I need. Oops. I just need one more file. But so what I wanted to show is that I can still just do what I did before. Not that one, but the others. So I can still just deploy my application. So it doesn't really change the fact that I've gone from having my own cluster locally to having a cluster running in the cloud, and I'm making the exact same application. The power of this is sort of by having infrastructure as code, by having these things defined as a recipe, as a way of doing things, it's very easy to move it around. And so the real power in making this type of technological move is not in the fact that you get Kubernetes. That's great, sure. I mean, that does something. But it's in the fact that you've finally gone and defined, what does it mean for me to run my little .NET application? What's the recipe for the dependencies? How does it look when I run it? What do I need to do? So it's not necessarily the technology that does the jump. It's the organizational change of having to define what are we doing and why are we doing it. Actually, I have the code lying here, but it seems like I've made a mockery of it when I was jumping back and forth between Linux and Windows. I was trying to make this work for Windows originally. Don't ask me why necessarily. But here we have the ingress file for Azure, and I think that's the interesting one. I'm going to skip the load balancer in favor of time. There are different ways to expose access to the cluster, and one of them is to run with a load balancer set up by Azure. In this case, we will run with this one, assuming this is the right one. We'll find out in a sec. It's the dangers of live demos. What did I call it? I called it Ingress Azure. What? I might not have saved the file. Aha, see? So what this does is that it instead takes a cloud native concept, which is Azure in this case, and then I ask them to make me a load balancer and them to do the routing for me, and I get their security and their options. That's one of the things that I do like about Kubernetes is depending on where you run it, you can really tap into a lot of these other things around. And if I've done this right, then at some point in the very near future, Azure's going to put out, here we are, an IP address, which is not quite ready. I just want to copy that, and then I'm going to come back to my host file, and then instead of this one, I'll do this one. It's the same. How many R's do I have? Quite a few. Well, a couple, right? Well, almost. Actually, I probably need to outcomment the other one. Sorry about that. And so if I did this right, yeah, now we're running in Azure. And so really the point of this is that the technology is really worthwhile, and like this is how you can actually do migrations. This is a very bare bones, and most applications will be a lot more complex than what I just showed. But this actually works as long as you go through, figure out all the dependencies, figure out all the things you do, and then massage the culture at the same time. Because I can do this because there's nobody screaming at me that I'm not doing it in the insecure way, I'm not doing it in the wrong way. I'm not doing any of this in a way that's unfortunate. And so while you're doing it, really what you're looking out for is the four horsemen of any technology change. New is not better. In a lot of cases, new is just new. What is better is that it forces you to think about a concept from a different angle. It forces you to think about why you're doing it. What need is it that you have, and what is the problem that you're trying to solve? And you often run into this problem, that nobody wants to work with whatever technology you were doing before. And you have a transitional phase where it's going to be running in the old way. It's going to be running in the VM while we're still doing the Kubernetes thing for quite a while. Usually it's at least a quarter of a year, even if you're very good at what you do. And cloud doesn't make it better. Kubernetes doesn't make it better. You still have some of the same problems. So if you're not dealing with sort of the fundamental flaws in your software, what you did for you is you made something much more complex and new, and you're having to learn, all of you, how to work with that. So now everybody needs to learn Docker, they need to learn Kubernetes, they need to learn how to work with Azure. That's three pretty big technologies that you weren't dealing with before that you're now all needing to understand. Similarly, compliance and security is a fun one, right? Their job is to basically hold you back and make sure that you do things that make sense. And quite often it's to take that beautiful Porsche that you just got in Azure and then shove it back on a horse carriage and say you can't go any faster than that, it's going too fast, we can't control it. So you also sort of need to deal with in what context are you running and why. And even if people go, well, cloud is dangerous, cloud is unsafe, or the opposite, cloud is the only thing you can do, you still have to sort of have that base question of why are you doing the thing? What are you getting out of the deal and what are you losing? Similarly, we have this idea of platform engineering. For those of you who don't know what that means, it is the idea that you take a team of people, in this case Kubernetes experts, you put them in a team and you make them have services that you can then take on so that you don't need to take on the complexity that I just showed you. But a lot of companies, what they end up doing is not platform engineering. So before they had a platform, they would then send a ticket to the guy who knew how to do the thing. And after they get a platform, what they really made is an API so that he can automate his tickets even faster in ServiceNow or whatever you guys use, and then never get to them anyway, right? The whole point of this is if you're not fully automating a solution, if I can't make it so that, some random developer in my company, in this case, can just go and click a button and get a Kubernetes cluster and he doesn't understand how and he doesn't need to, then you haven't really done a platform. So it's about the way we work, not necessarily the technology we work on. You can do this with VMs. You can make a fully automated solution where I drop my app in some repository and a team you have of highly specialized people will just make a VM for you, spin it up the right way, put it in the network where it needs to go, and make it run. You don't need Kubernetes for that. And then finally, we have this guy, right? So enterprise architects want one diagram to rule them all, and the more technologies you throw in the mix, the worse that gets, the harder it gets, because they really want the one way of doing things. And to my knowledge, at least, what you end up with is a bunch of different services written for different things with different needs that you just can't mainstream and make the same. So you have to have these trade-offs. You have to think about why you're doing things. You have to figure out how to do it differently. And really, that's all. Thank you very much, everyone. And I think I even made a few minutes for questions. I did. Fantastic. If you want to talk to me, my LinkedIn or my email is probably a good bet. And if you want to look at the code that I ran or the configuration that I ran today, then I have a public repo that you're more than welcome to have a look at. It's nothing insane. It's nothing that you probably can't find on the internet if you look at various examples, but this one should work, and you can deploy it into your favorite cloud using some version of that. You might have to change the Azure bit. Thank you very much. Were there any questions? All right, then I won't torture you. Come talk to me if you want, and otherwise have a wonderful evening.
So thank you everyone. Thank you David, and thank you Lars before. And that's all from the program.
I just wanted to show you that we have I've turned on the both discussion and issues on the repository, but I've also put two notes on. We can just chat on the meetup group. So it's already there, or there's a link to the demo that I showed you. If you want to use this, you've got two options. You can fork it, and it's going to give you the entire history, or you can just use the template function. I use that as well. It's going to give you a shallow copy. It's just going to get the latest, head on masters. You just get one commit containing it all, and you can continue from there. If you want to, we had 3 issues from the community, right? That you will go home and explore and get back to the community and report to us, right? So you know who you are, right? So get that, right? That could be really cool. Let's try to see if we can actually get a community up and running, right? So keep in touch, right? Thanks for coming.
I can add my repo there as well.
All right, so we actually got Nicholas and
That's great.